Hey guys, welcome to 11.2. Hopefully 11.1 went okay. 11.1 was all about one set of data, and so we called it a one-way table. Today we're going to look at two-way tables. Again, please feel free to pause at any time as I'm going to move kind of quickly so that you can go as quickly or slowly as you need to. So here's kind of an introduction, but we're looking at two groups or two samples now. And so we need a new test-ish. It's a little bit different. It's called the chi-square test for homogeneity. It's for a two-way test, so notice that it says chi-square dash test. It does not have the GOF on it, so you will look for that in your calculator. So this is a test to determine whether the distribution of a categorical variable is the same for each of several populations or treatments. We hypothesize that the distribution does not change from group to group. The test looks for differences large enough to step beyond what we might expect from a random sample-to-sample variation. It can reveal a large deviation in a single category, or small but persistent differences over all of the categories, or anything in between. Homogeneity means that things are the same, so that's what we are testing. So what is different? Well, as we talked about already, you are going to choose a different test in your calculator. We are actually going to enter the data into matrices instead of lists. And the degrees of freedom is going to change, so we are going to take the number of rows minus 1 times the number of columns minus 1. So here is how you would begin a chi-square test for homogeneity. And notice that the H0, the null hypothesis, says there is no difference in the distribution of the categorical variable, whereas the alternative says there is a difference. So let's take a look at an example. It says market researchers suspect that the background music may affect the mood and buying behavior of customers. One study in a Mediterranean restaurant compared 3 randomly assigned treatments: no music, French accordion music, and Italian string music. Under each condition, the researchers recorded the numbers of customers who ordered French, Italian, and other entrees. The data is below. So, the first thing we have to do is look at the expected counts. We have to calculate what would be expected. So, to do this, we are going to assume that the null hypothesis is true and that there is no difference depending on what kind of music is playing. And so if you look at the French music, okay, the probability of ordering French just in general is 99 out of 243. How many entrees were ordered when no music was playing? That's 84. So if we wanted to know the expected number of French entrees ordered when there was no music playing, the expected number would be 34.22. And again, we're not going to round these to the nearest whole number because this is the average over time. So notice I filled in the expected counts there as 34.22. So what you will notice is that you have a row total, you have a column total, you multiply those and you divide by the total number n, 243. That will be the same for each of these probabilities or expected counts. That pattern carries through, but let's look at one more. How about the probability of ordering Italian? The probability of ordering Italian is 31 out of 243. How many entrees were ordered when French music was playing? That's 75. So the expected number of Italian entrees ordered when French music is playing is 31 times 75 divided by 243, and you get 9.57. And I filled that in for us. You could continue this pattern and find all the expected counts, which they would expect that you do. And there they are. So we have a couple rules here. The conditions that you check are the same. The test statistic itself is the same. The expected count is different, as are the degrees of freedom. So take a moment to take that in. Okay, so now if you wanted to calculate the test statistic by hand, you could do that. You just have more pieces of it, if you will. But you do it the same way as when we had a one-way table. Okay, so does the background music influence what customers buy? This is state plan do conclude. We're looking for convincing evidence. We're going to do a test. So we are going to state our hypotheses. We are going to say that there is, as for our null, there is no difference in the true distribution of entrees ordered at this restaurant when no music, French accordion music, or Italian strings music is played. So then the alternative would be that there is a difference. And again, feel free to pause at any time because I know I'm moving fast. So what's the plan? The plan is we're going to do a chi-square test with degrees of freedom of 4. How did I get that? Well, we have a table of values that's 3 by 3, so you're going to subtract 1 from the row and the column. So you have 2 times 2 is 4. Again, we are going to use a significance level of 5%, and we also have to check the conditions. So this was an experiment. Assignment of random treatment was explained in the introduction to this. The 10% rule, therefore, does not apply because we did not sample. And all of our expected values are greater than 5. Again, they want to see the expected values. Okay, so let's go to the do. Remember, we are now looking at matrices. So in your calculator, you would go to second, and then you're going to look for matrix, and that's about 3 buttons below the second button. It's the one below the math button. And you are going to put your observed values in matrix A, your expected counts in matrix B. And so it's going to look like this. Now, how do you get those values in there? You have to go over to Edit, and then you edit matrix A and you edit matrix B. So now let's do a test. We're going to do a chi-square test, not the other one, not the goodness of fit. So we are going to choose option C here. Observed is matrix A, expected is matrix B. Calculate. We get a p-value of 0.0011. We get a test statistic of 18.28. So what should we conclude? Pause and think about this for a minute. Okay, same rules apply. So it says because the p-value, 0.0011, is less than our default alpha equals 0.05 significance level, we reject the null hypothesis. So what does that tell us? We have convincing evidence of a difference in the distributions of entrees ordered at this restaurant when no music, French accordion music, or Italian string music is played. Furthermore, the random assignment allows us to say that the difference is actually caused by the music that's played. So because this is an experiment, you have to think about that. And now let's go ahead and take a moment to interpret the p-value. So this is different from drawing your conclusion of the test, but actually take a moment, pause, and interpret the p-value. Assuming that there is no difference, because that's our null, in the true distributions of entrees ordered in this restaurant when no music, French accordion music, or Italian string music is played, there is a 0.0011 probability of observing a difference in the distributions of entrees ordered among the 3 treatment groups, as large or larger than the ones in this study. Okay, so now if they ask you for a follow-up analysis, you want to look at this data and see which one of these values is going to contribute to the chi-square test statistic the most. You only have to do this if they specifically ask you. So it says looking at the output here, we're looking for the largest contribution number here, so we're looking here. Okay, so it says Expected counts are printed below the observed counts. Chi-square contributions are printed below. Okay, so these numbers here are the ones that contribute to the chi-square test statistic. You can see that these two values are much larger than the rest. So it says, looking at the output, we see that just 2 of the 9 components that make up the chi-square test statistic contribute 14, almost 77% of the total 18.28. They want you to go a little bit further, though, and it says we are led to a specific conclusion. Orders of Italian entrees are strongly affected by Italian and French music. So notice the expected counts are printed below the observed. So we only had one French, when this French music was played, we only had one person order, where we expected 9.57, in here we have 19 versus the expected 10.72. That's what gives us such a large test statistic here. Okay, so this is just kind of a summary, and I am going to end the video here, and I will do another one for the chi-square test for independence.